Total, how many students you have in your class?
So 123.
So who is your seer?
So section B is me, Rohit Kundu.
Okay, but I think I don't have your number. So I am sharing this link. So YouTube
Yes, sir, I
live
shared with the
link to
class.
Ankit.
So I've shared with the class.
Jaishwal. In your WhatsApp, I shared the link.
Okay, sir.
Those who can't join, you just share the link to them so that they can join.
Yes, sir, we have already shared the link with the class.
Then okay. I think now everybody can join, and I can also see the people who are watching the. Okay, so let now start the discussion. So this is the circuit for performing the open circuit test in laboratory. Now this is the transformer which you can see at the right is the transformer under test. So every transformer when it is kept idle, it is not in operation. The winding two coils are designated as low voltage and high voltage winding. Okay, it's not primary or secondary. So when the transformer is kept idle, it is not in under any operation. We should say low voltage coil or low voltage winding, and another coil we should designate as high voltage winding. So these two are the windings we can say. So another name of this transformer is the two winding transformer because we have two winding. So there are three winding transformer which has the third winding as a tertiary winding. But here we have only the two windings in present in the transformer. Okay. Now for doing this open circuit test, generally what we do, we keep all the instruments, measuring instruments in the low voltage side, and the high voltage side we keep open. Okay, so that is the normal procedure we follow. That during the open circuit test, all the instruments, all the measuring instruments, we connect at the low voltage side, and high voltage side is kept open, and there a voltmeter is connected. Okay, so what are the other meters which we use for this open circuit test? So other meters are ammeter, one ammeter, one voltmeter, and one wattmeter. So these are the three essential meters, measuring instruments we have to use at the low voltage side. Frequency meter sometimes we use, or sometimes we don't require this frequency meter. So these three meters are very important: one ammeter, one voltmeter, another wattmeter. So am I audible clearly to all?
Yes, sir.
Yes, sir.
Okay. Uh, Now, uh, can you tell me that why we do like this? Why we keep all the measuring instruments in the low voltage side and the high voltage side is kept open? I'm just asking you because all this you have studied in machine one. So can you
Sir,
answer this?
because in open circuit test we have to apply the rated voltage. So on the high voltage side, the rated voltage is much higher than the low voltage side. So a voltmeter of such a high rating is very difficult to find and very difficult to arrange. So it is easier to perform this test on the low voltage side.
Okay. Okay. That is one reason. Another.
Sir, in open circuit test, the current is 2 to 3% of the rated current. So the current is very low. So the instrument won't get damaged.
Instrument.
Sir, also
Not
when,
get damaged.
sir, also when we prefer LV side for OC test, the high rating instruments are not available and like accuracy will be high for low rating instruments.
I'm not getting. Okay. What you are trying to say?
The accuracy will be more, sir.
The current. No, the current in open circuit. What will be the current? How much current can flow?
Very low, 2 to 3% of
2 to
rated.
3%, sir.
Very low, sir.
Okay. Why? Why such low current will flow?
Because it is
Secondary is open, so no load is there.
High voltage side
The
will be
no
zero.
load current of transformer is small, sir.
Huh?
Sir, because no load current is very small, sir. Because in the high voltage side,
Sir,
the
because sir, very
voltage will be zero.
low current is required for magnetizing, sir. Only that's why.
Okay.
Sir,
Okay.
another reason of
So that means there.
Only
Huh?
sir, actually, sir, the objective of open circuit test is to determine the core loss. Now, when on the low voltage side we are applying voltage and current, then the wattmeter is which we are getting core loss as well as the no load loss. And through this wattmeter reading. Now, as you're considering that the
Okay.
wattmeter reading is the core loss, now if the no load loss is less, then we can easily neglect that. So in order to achieve, we have to use a low voltage side, as we can get a core loss by neglecting the no load current.
I am getting different answer, but the thing is, you are correct. We should keep our meters at the low voltage side. The first reason is that if we keep in the high voltage side, then the rating of the voltmeter, especially voltmeter, will be required is high. In that case, what we can do, we can use some sort of PT, potential transformer. We can keep the voltage down, then we can use our normal range voltmeters. So that is one option. Sometimes it is not possible to connect the meter in the low voltage side. Then what we do, we use some potential transformer, PT, and we can use our normal voltmeter. So that is one thing. Another thing, another problem with this pressure coil of the wattmeter, because you can see here also in the circuit diagram that uh, wattmeter has two coils. One senses the current, another senses the pressure or the voltage. So the voltage measuring coil of wattmeter is called the pressure coil. Now here the pressure coil rating of the wattmeter will be required very high if we keep the wattmeter, if we connect the wattmeter the high voltage side. So that is one reason. Another second reason is uh, the current which we expect in open circuit is very less, because the circuit is open. If the circuit is open, then how the current is flowing? The current will flow in the open circuit, which is also called in the no load condition of the transformer. The current flows in the coil, in the primary coil. Here, the primary coil is low voltage because we have connected the supply at the low voltage side. The primary current will be very low. And why? Because we should, ideally, to say there should not be any current in the open circuit, but practically you have to magnetize the core. Otherwise, how it will act as a transformer? So it needs some magnetizing current. Okay, so it should have some magnetizing current, and in the process of magnetization, there are few losses in the magnetic core itself to cater. Another part of the current is drawn from the supply. Okay, so that means in this condition, in this open circuit condition, uh, there are two currents which are drawn from the supply. One is called the magnetizing current, another is called the core loss component of current. So you can write down that. Today I don't have this whiteboard because I am taking this class from our department. So you can write down that in the open circuit condition, the transformer primary takes two currents, two component of currents. One is magnetizing current, which we write as IM, and another is the core loss component of current, or IC. And the net current, which is drawn from the primary or the supply, is called the no load component of current, I0. Now this I0 is the summation of IM plus IC, but this summation would be vector summation. So you should write that I naught is a vector, I0 is a vector, which is equal to I M vector plus IC vector. Okay. So these are these two the currents which flows in the open circuit condition. But as you mentioned that this current is very low compared to the rated value of the current. Now what is the rated value of the current? The rated value of the current is that for which the winding is designed. Okay, so during the design of the transformer, during the selection of the gauge of the or cross section of the winding, cross section of the conductor, we take some current. Okay, so that is the rated current, or sometimes it is also called the full load current. And that value also we can get from the KVA rating and the voltage rating of the transformer from the nameplate. Okay, so that is called the rated current. Now, at this condition, the current which flows through the primary is very low. It is almost 2 to 3%, as you have mentioned, compared to the rated current. Okay, now if we connect the meters, that is the ammeter, not only the ammeter, also the current coil of the wattmeter, because current coil of the wattmeter is similar to ammeter. It senses the current for measuring the watt. Okay, so these two things, that is the current coil of the wattmeter and the ammeter. Okay, so that current, as the current is very low, sometimes it cannot measure that low current, or it can measure, but the percent of error can be high. Okay, so that is the reason for which we should not connect the meters at the high voltage side. We should connect the meters, that the 3 meters, main 3 meters, ammeter, voltmeter, and wattmeter. So these are the three main meters we should connect in the low voltage side. Okay. Now, what is the objective of performing this open circuit and short circuit test? The main objective of performing this open circuit and short circuit test is that we want to find out different parameters. We want to determine different parameters So I'm back again. Can you hear me?
Yes, sir.
Yes, sir.
Sir, for the last 2 minutes, we haven't heard anything.
Okay, maybe. So I'm just repeating that. Actually, I was discussing that uh, why we should go for these two tests. What is the objective of the open circuit and short circuit test? So as you have already also mentioned that the objective of open circuit test to measure the core loss. So that is another objective. But main objective of doing this open circuit test is to measure the parameters of equivalent circuit of transformer. So which parameter we can we will extract from this open circuit test?
Shunt
These two
branch
parameters are the shunt branch parameter of this equivalent circuit. Shunt branch parameter means there are two parameters. One is the magnetizing inductance, another is the core loss component of resistance. Okay, so magnetizing inductance, magnetizing reactance, and core loss component of resistance. So these two are the parameter. XM, magnetizing reactance, and RC, capital RC, capital XM, capital RC. So these two are the parameters which we determine from this open circuit test. Okay. So do you have any doubt, any question on this? You can ask. Okay. Now I can ask you some question that why somebody told me that I also forgot to mention that point. That is a very important point that the open circuit test should be performed at rated voltage only. Okay, so it should be performed rated voltage only. So why like that?
To
Why the
calculate
open circuit test should be performed at voltage only?
to calculate the no load parameter, because the no load parameters is loss, no load loss, core loss is fully dependent on voltage square. So to determine the core loss, rated core loss, we have to give rated voltage.
Hmm. Okay, but that is not our only objective of open circuit test. Somebody send me a chat, Victor. Sir, I am not able to hear you in YouTube stream, not in Zoom. Is it so?
No, sir, I think like when you resumed in the Zoom after that, so maybe there is some lag in YouTube, but in the Zoom meeting, it is audible.
Okay. Okay, there may be, obviously, there should be some lag between this Zoom streaming and that streaming in YouTube. But I think in Zoom it is audible. Anyway, so what is
Yes,
the
sir.
answer? Why
Maybe,
we
sir,
go for
because
the rated voltage only?
in rated voltage, there will be maximum flux in the core.
Not maximum, that is the rated value of the flux. Anyway, so first who answered this, that he is also correct, that the core loss which we get, because from the core loss only we will extract the RC. That core loss component of resistance that we'll get from the core loss only. Okay. Now the core loss depends on the voltage, input voltage. If we change the input voltage, then the core loss will vary. So therefore, in this experiment, if you see, we have kept a variac. Why? To show the change in core loss with voltage. So in this particular experiment, if you go through the steps, then you will see here in this experiment, you have to change the voltage gradually from 0 to the 120% of the rated voltage. Suppose the rated voltage is 110. Then you have to start with 10 volts, 20 volts, 30 volts. In this way, you have to change the input voltage to the primary of the transformer to 120% of the rated voltage. Why so? Because we want to trace the, or we want to see that how the core loss, changes with respect to the input voltage. Okay, but ideally the open circuit test should be performed at the rated voltage only. One more chat I am getting. Okay, is that clear? So that is the reason for which we perform this test at the rated voltage. So now what I will do, I will stop this share and I will go for the actual experimental setup. Okay. Can you see this?
Yes, sir.
Yes, sir. Yes.
So this is the transformer. I think you have already seen. You have already seen this type of transformer during your experiments in second year. Okay. So this is a 3 kVA single phase transformer. Okay, and the voltage ratios are mentioned 110 by 220 volts, 50 hertz, AC with taps at 50% and 86.6%. The transformer is made by Neo Teletronics Private Limited and it has 8 terminals, 4 terminals each side. Now, if it is a 2-winding transformer, then it should have how many terminals minimum? Suppose it's a 2-winding single phase transformer. So minimum how many terminals should be
4,
there?
sir. 4.
4. But here you have 8. So that means you should know. So what are the other terminals?
Those are
okay.
terminals.
So for that, what is the general procedure? Always we have to start with the continuity test. That also I think you have performed during the earlier experiments with this transformer, isn't it? So continuity
Yes,
test
sir.
means you can take a multimeter and you have to select the resistance measurement mode of the multimeter, and you have to connect 2 leads of the multimeter with 2 terminals. Okay, and if the multimeter shows the full deflection, then you can say there is some connectivity. So it is continuous. Okay, suppose from the left, if we go for 2 terminals, 2 consecutive terminals, if it shows a continuity, that means what it says? It says that
They're on
the
the
coil
same.
exists between these 2 terminals. Okay, now you go for the next 2 terminals. That means the 2 and 3. If you don't get any continuity, that means you can say there is no coil exist. Now if you go for the 3 and 4, again if you get the continuity, that means you can say there is a coil. And in this particular transformer, you will get that only. So that means between 1 and 2, you have a coil. Between 3 and 4, you have another coil. And these two coils are basically for the low voltage coils. That means the 110 volt coils. So that means in the 110 volt side, you have two different coils, electrically isolated coils. Okay. So one is connected between 1 and 2 terminal. Another coil is connected between 3 and 4 terminals. Am I clear? Okay. So from this particular transformer, the side from which you can read the nameplate in proper way, from this side you will have the low voltage side. যেদিক থেকে আমরা নেমপ্লেটটা পড়তে পাচ্ছি সেদিকের যে সাইডটা সেটা হচ্ছে লো ভোল্টেজ সাইড. So this side is basically the low voltage side for this particular transformer. Okay, and the other side is the high voltage side. And I already told you about the meters. So this is the voltmeter which we'll use for the voltmeter which will be connected at the high voltage side. Because I think you have seen that at the high voltage side also one voltmeter is connected. So this voltmeter will be used for the high voltage side. Now this is the watt meter. You can see this is the meter, and watt meter has different current coils and different pressure coils. So the terminals which you can see at the top, these are all pressure coil terminals. Okay. Now current coil terminals are on other side. Now this is the ammeter. Okay, so you see the range is 0 to 3 ampere and 0 to 10 ampere. So there are two ranges. So this ammeter will be used for measuring the no load current, I0. And this is another voltage. This voltage will be used for measuring the excitation voltage at the low voltage side. And this is the variac. Okay, so as you know, the variac is basically a auto transformer. We can say variable auto transformer. Okay, so here in that variac will connect our input to this 110. Okay, and common, because the available voltage in our laboratory is 110 volt AC. So therefore, here we'll connect the 110 volt AC to these two terminals. So 110 terminals and these C terminals. Okay, and we'll take the output from these two terminals, C and E terminals. That means the output will be collected from C and E terminals. Okay, so these are the panels. So there are two panel experimental board, one on the left, another on the right, and fuses are connected there. In this panel, only one discontinuity is there in each line. In each line, only one discontinuity is there. So can you tell me how these discontinuities are used during the experiment? So these are the discontinuities. You just see. Can you see my pointer, mouse pointer?
Yes, sir.
So these are the only discontinuity in this line. Okay. Can you tell me how these discontinuities are used during connections? Anybody?
It's a parallel connection.
No. These discontinuities are used for the series connection. Suppose if we want to connect some series apparatus like ammeter or current coil.
Connect ammeter.
Yes.
Okay. Ammeter or current coil, because the ammeter is a series apparatus. Current coil upon wattmeter also is a series apparatus. So this type of series apparatus we connect like this. So one terminal will be connected at the top, another will be at the bottom. So this is how these discontinuities are used. Now, if we need more than two discontinuities, more than two series apparatus should be connected. So how we can manage that? By using this board only, because we generally suggest that all the connections should be via the board. Okay, suppose we need more than three series apparatus to be connected during the connection. So how we can manage that? Do you have any suggestion? We have two discontinuities, but we have three series apparatus. Any suggestion?
The bottom two.
Which one?
We can take the connection to the other side of the board.
Okay, but then we will get four. Now, suppose we have only this panel.
So then we
don't
can
have the
connect
other
from,
panel.
sir, from one
If we
device.
have the
we'll
other
connect
panel,
to
then
other.
we can go there.
No, sir, from one
Huh?
device we can connect to the other device, and then from that device, last device, we can again connect back.
No, that is not recommended in our laboratories. That I already mentioned at the beginning.
Sir, in the
So
top two,
every connection generally we do via the board terminals.
Sir, we can
I
disconnect.
think that
the
you have
fuse
already
on the
seen
top.
sir,
during the
To fuse
experiment.
wire
in
on
the
the
top two, sir, in the top 2 pointers, the wire is connected from the
wire.
external side. Remove the wire and
Yes,
use
the
it
wire
as
can
a
be removed.
discontinuity.
Where?
So the fuse wire can be removed
Okay.
from the top.
Correct. That means there are two FETs. So generally two fuse wires are not required. So one fuse is enough to protect any circuit. So that means one fuse wire you can remove and you can connect another series apparatus there. Okay, so this approach generally we took during the fan experiment, the experiment of the ceiling fan. There we have different series apparatus like the series regulator, voltage regulator, ammeter, wattmeter. Okay, so there we took this type of measure. Is that clear? So if we have more than two series apparatus, either we can go for that side. If we go that side, then we'll get four discontinuities. So that is another possibility. But here you see, here this discontinuity will be required for the wattmeter, for this variac itself. Then we have to go for the other panel. Okay. So let me stop this share. Another video I'll show you. So this is the connections. I'm going to show you. So you see, these are the input. So at the top, I have connected the 110 volt. I am taking this 110 volt from these two terminals and I am connecting with the input of the variac. So as I already told you, the input should be connected between this 110 and C. and the output will be collected from C and E. So between the input and output, one terminal is common. That is also depicted in the figure of the instruction sheet. Okay, so these two are the, okay. So next video. So what we have done, we have connected the input to this, and output directly we have taken on the other panel. We haven't used this panel. We have taken the output directly to the other panel, and there we are measuring the voltage. So that means this is basically the voltmeter which is used for measuring the primary voltage or the low voltage side voltage. And for voltmeter, we use this type of thin wires. So this voltmeter will measure the V1. So this is the voltmeter connected for measuring V1. Okay. Now you see what we are connecting now. Is this a parallel apparatus or series apparatus?
Series apparatus.
So that means either ammeter or current coil we are connecting, isn't it? So let's see. So you see we are connecting the ammeters by these two wires. So that means it is obvious that another discontinuity we have that will be used for connecting what? So another discontinuity that we have in the other line that will be used for connecting what?
Current coil.
Current coil of the
Current coil.
wattmeter.
Current coil of the wattmeter. So let's see. Now he is connecting the current coil. So you see, I told you that the current coil is placed on the other side, and the top you have the these are the all pressure coils and pressure coil terminals differ for different rating, and these are the current coils of different rating. Now for this open circuit and short circuit test, we need a different range of current coil and pressure coil. So therefore this wattmeter is a very specialized wattmeter which is used for this open circuit and short circuit test only. And these are very rare wattmeters. Nowadays this type of wattmeters are very rare in market, which having multiple current coil and multiple pressure coil. So initially we are connecting the what is the, you see the rating. So 2.5 ampere range we have taken because in the open circuit test, the current which will flow through the circuit will be very less. If we take 10 ampere, then we'll lose the sensitivity. Isn't it? So therefore the minimum range of the current coil available in this wattmeter we have used. So that means now we have, so this is the, this you should remember always that voltmeter, pressure coil, these are not the important part of the circuit, but the series apparatus are the important part of the circuit. If there is any problem or is there any issues in the series apparatus. If the series apparatus is the coil is broken, then the circuit will not be through. Okay, so that means the series apparatus is the important part of the circuit itself. So therefore, we first connect the series apparatus.
Sir, are the output
Any question?
Sir, are the output terminals of the variac connected to the left panel or right panel?
Right panel. That I told, na. So input is connected from the left panel and the output is directly connected to the right panel. Okay, so we have a different kind of wire which has one side wooden handle, another side is socket. So we have used two such cables which has one side wooden handle, another side is socket. So socket side is connected with the C and E terminal of the variac, and the two wooden handles are connected with the right panel of this experimental table. Is that clear?
Yes, sir.
So what he has connected? Can you tell me? Only one wire he has connected. Now what is that? You see, only one wire he has connected now. For what? And that is also at the left line, not at the right line.
Pressure coil.
What is that? Again, I am showing you. You just see he's connecting a thin cable on the left line and only one. Because you know that any instrument will have at least two cables out of it, isn't it? But here he is now connecting only one. So what is that cable for?
It is for pressure coil.
Why it is one?
One is sorted with CC.
Okay, correct. So one is already shorted with CC. So that shorting I think you have already seen in the wattmeter side, isn't it? So in the wattmeter side, that is shorted by a fuse wire. Okay, and as the current coil is connected in the right line, okay, so therefore he is connecting the pressure coil terminal to the left line so that they can measure the voltage. So voltage should be connected in parallel, should be connected across. So therefore we are using the left line to connect the other terminal of the pressure coil. So one terminal of the pressure coil is already sorted with the current coil. Is it clear? Now I think, okay, so you see it is connected with the pressure coil. Now he has rotated because the low voltage side we should excite. But what we can do, we can make the two coils available in the low voltage side parallel. Okay, so what we are doing, we are connecting two different coils of 110 volt available in the low voltage side parallel. And during this parallel connection, you should know the polarity. As you already know that the terminal number 1 and 3 has same polarity and 2 and 4 have same polarity. So therefore, he is sorting 1 and 3 and 2 and 4. So this is how we are making two coils in the left parallel. Then we'll supply in any of the coils, so either 1 and 2 or 3 and 4, because both are connected in parallel. Okay, so let me share one more video. Now we are giving the excitation to one of the low voltage coil. So 1 and 2. Terminal 1 and 2 we are connecting with the supply. Okay, so this we have connected with the supply. So this is how the circuit becomes complete. So one more connection is left. That is the connection of V2 voltmeter, which will measure the voltage of the high voltage side. So this is how we are connecting the voltmeter for measuring high voltage side voltage. And you should carefully select the range because the high voltage side will give you around up to 220 volts. But initially he has connected with 150 volts because when we'll start the experiment with lower voltage, suppose 10 volts, then only 20 volts will be developed in the high voltage side. So therefore he has started with the minimum range of the voltmeter. Is there any doubt regarding this open circuit test setup? So any doubt? Okay. Now we will come back to the circuit. So that means this is how we have connected ammeter, voltmeter and wattmeter for performing the open circuit test. Now, during the experiments as given in the steps, we'll increase the voltage. So you see, connect the single phase transformer as shown in the figure that we have seen. Now keeping the high voltage side transformer, high voltage side of the transformer open, energize the transformer on the low voltage side using all the coils. So that means all the coils means there are two coils. So we have used both the coils by making parallel. Okay, so that means we did that. Now vary the applied voltage, change the applied voltage at rated frequency. So that means frequency we haven't measured, but we can also measure the what is the frequency. But if it is other than 50 hertz, we can't do anything right now. So therefore, it is immaterial to measure the frequency, but it should be done at the rated frequency. Otherwise, we have to do some correction for frequency. So vary the applied voltage at rated frequency in steps of 10 volts. So that means we have to start with 10 volts, then you have to change in steps of 10 volts, the 10, 20, 30, 40. This is how we have to increase the voltage up to 130 volts. Okay, 110 is the rated voltage. We have to take the reading up to 130 volts. And at each step, we have to record the V1, V2, W and I. So these four readings we have to. Okay. Now can you tell me that why V1 and V2 both we are recording?
To calculate voltage ratio.
Turn ratio.
Voltage ratio calculate.
Okay, but if we take this at 110 volt, that will give me the perfect one. Na? Actual one I will get at the 100 rated voltage only. Why we are recording this V1 and V2 for all voltages? Now what type of curve we should get if we plot V1 and V2? Suppose if we plot V1 versus V2, what kind of curve we should get? Okay, so ideally that should be a straight line, isn't it? Ideally that should be a straight line.
Yes, sir.
But if we track the core loss, that core loss will be saturating. If we go beyond the rated voltage, then it will be slowly saturating. Obviously passing through the origin. Because for 0 voltage, you will get the 0 voltage at another side. Okay. So anyway, so we can get a different core loss for different input voltages. Now, once we have this ammeter, pressure coil and voltmeter reading, so how we'll do the calculation? The calculations are very simple. From this wattmeter reading, directly we'll get the core loss, but you have to take that wattmeter reading which corresponding to the 110 volts, that is the rated voltage. Only that wattmeter reading you have to take. So that will give you the rated core loss. The rated core loss you will get from the wattmeter reading, but at 110 volts given to the low voltage side, not at the high voltage side. Okay, so if you measure the core loss when the high voltage side reads 110 volts, then that will be wrong. Okay, so you have to take the wattmeter reading corresponding to the 110 volt reading on the low voltage side. Okay, and at this 110 volts at the low voltage side, whatever the current you will get from the ammeter, that is basically the no load current I naught. Okay, so that is the I naught. So that means the I naught and PC directly you are getting the core loss and the no load current directly you are getting. Now, how we will get the other currents? Okay, now one thing you can do that you can measure the VA. So voltmeter reading you have, that is 110 volt, and ammeter reading also you have. Suppose the ammeter reading is suppose 1 ampere. Okay, so this 110 into 1, so that is the VA, volt ampere. And suppose the wattmeter reads 30 volts. So 30 by 110, what is that?
Cos phi 0.
What is that?
No load. No load power factor.
There is a no load power factor. So that is the no load power factor. Cos phi 0, correct. So that is a no load power factor. Okay. Now if we multiply cos phi 0 with I0, then what I will get?
Core loss component of the current.
I will get the IC. Okay. So I will get the IC. And if we take the phi from this cos phi 0, that is phi 0 from this cos phi 0, and if I multiply sin phi 0 with the I naught, then I will get the IM, magnetizing current. So this is how I can separate the two components of current at no load condition. One is the magnetizing current and is the core loss component of current. Okay, so this is how you can separate two currents, and you can also find out the core loss by how? Just by divide the
PC by
I square of the IC square. So W by IC square will give you the RC value, isn't it? So this is how you can measure the core loss resistance. Also, you can measure the magnetizing inductance in this way. Can you tell me how you can measure the magnetizing inductance?
Upon 10 phi 0.
Divide V1 by IM.
Okay. V1
By
by
RC
IM
upon 10
will
by
give you the reactance. Okay, so that you will get the reactance value. I am asking the inductance, magnetizing inductance.
By 2 pi f.
So divide 2 pi f from it.
Divided by 314.
114.
Isn't it? Okay. Now we'll go for the next test, that is the short circuit test. So short circuit test is the opposite. We perform the test at the high voltage side and the low voltage side is short circuited.
Sir.
All the measuring instruments are kept at the high voltage side. Anything you want to ask?
Sir, can you again please mention the reason of using V2 at high voltage side?
Which one?
The reason of using V2.
Which one?
Voltmeter. The using of voltmeter V2 on high voltage side. What is the reason? Can tell me?
Okay, so we want to track the voltmeter with respect to the high voltage and the low voltage. So there is a plot of curve is there, I think, at the report. You see the first run itself. Have you seen this part?
Yes, sir.
We track
the
V1 versus. No. Yes, we want to see that whether the V2 is getting saturated with respect to V1 or not. So in the operating region, V2 should not saturated with respect to V1. Okay, so we want to see the linearity. Is that clear? So you want to see the linearity between the V1 and V2.
Okay, sir. Thank you. Understand.
So that should be a linear straight line passing through the origin, as I mentioned. But if it is not that, then we have to think.
Sir, we have calculated the RC using W by IC square, and how we have calculated the XM, magnetizing reactance.
He told na V by IM. The V1 which you will get by this magnetizing current which you are getting by multiplying sine phi 0 with I0, that is IM. So V1 by IM will give you the XM, isn't it?
Yes, sir.
Okay. As they are connected in parallel, so that means across this XM, which voltage is appeared? V1 voltage is appeared. Okay. So therefore, we can just divide the V1 by IM to get the XM value. Okay, once we get the XM magnetizing reactance value in ohm, then we can divide that by 2 pi f. Okay, so 2 into 3.14 into 50, that comes around 314. If we divide that value by 314, then we can get the magnetizing inductance or capital LM. Okay. Now come to this circuit test. In the short circuit test, we connect all the instruments at the high voltage side and low voltage side is short circuited. Again, it's similar reason is behind this. That is, first thing that you should say that the low voltage side, unlike the open circuit test, low voltage or short circuit test must be performed at rated current, at the rated current. Okay. So the open circuit test is performed at rated voltage and the short circuit test is performed at the rated current. Because what is the reason? Because from the short circuit test we try to determine the series branch parameter. That means the copper resistance and the leakage reactances. Copper resistances of the primary, copper resistance of the referred secondary, and leakage reactance of the primary and leakage reactance of the referred secondary. So these are the parameters we want to determine from this short circuit test. Okay. Now in this series branch will give you the rated power loss when the rated current will flow through them. Okay. So the power loss of this series branch depends on the current, not on the voltage. I don't know what is the voltage, but it depends on the rated current only. But in the open circuit test, the power loss in that case, which is called the core loss, that depends on the voltage, not on the current. So that is the difference. Have you understood? My objective is different. Here my objective is to determine the series branch parameter, and the series branch parameter power loss depends on the current, not on the voltage. So therefore, we are going for the rated current. Okay. And why we are shorting this? Rated current can also be generated by giving a rated voltage and a rated load. But we are not giving any rated load here. We are achieving this rated current by short circuiting the transformer. Why? Are you getting my point? My objective is to perform the test at rated rated current. But why I am short circuiting the transformer?
Sir, if rated voltage is applied, then much more power will be required for rated voltage and rated current.
No.
Sir, if we apply a rated load, then we will also record the power loss of the load, but we want only the power loss of the transformer.
Not the load. Not the load. The shunt branch will give you the rated power. So that means from the power rating you will get the both. So how you will segregate these two? If you apply a rated voltage and rated load, then the power, that wattmeter which will read, that is the summation of either your core loss and copper loss. So you couldn't segregate these two. But if we short circuit the transformer, and by that if we achieve the rated current, then the advantage is during the short circuit, the voltage drop is very low. It is 2 to 3% of the full load voltage. And as the voltage drop is very low, then we can neglect the shunt branch, because as we have already seen, the shunt branch depends on the voltage. Suppose instead of 110 volt, if only 2 volt is drop, then with respect to these 2 volts, so how much core loss you will get? Very less, isn't it? So therefore, to neglect this, so if we can neglect, then we can separate two losses very easily, isn't it? So therefore, we are achieving so our objective is to perform the test at rated current. But how we are achieving? We are achieving this rated current by short circuiting the transformer, so that the voltage drop can be very low. Is that clear? Is my point clear? Okay. Now here we are connecting all these meters at the high voltage side, because high voltage side of the transformer, the rated current is low from this VI equals V1 I1 equals to V2 I2. From this principle, you can say that low voltage side current is high, high voltage side current is low. Okay, so therefore you can get available ammeter and current coil of the wattmeter in that range. Otherwise, you have to use current transformer or CT for performing the short circuit test. To avoid this type of additional arrangement, we can keep the meters in the high voltage side, and we can perform the test with our available meters. Okay, so that is one reason. Another reason is as the voltage is very low, suppose 2 to 3 volts. Okay, so if we keep on the other side, low voltage side, voltage will be still low. Then you don't have that voltmeter to measure that low voltage. So you have to arrange some millivoltmeter for that, isn't it? For low voltage side, the voltage will be still low. So you have to arrange some millivoltmeter for that. So if we keep the voltage at the high voltage side, at least we can measure the voltage with our available voltmeters. So that is the reason for which we keep the measuring instruments in the high voltage side during the short circuit test. Okay, so now I will show you few video like the open circuit test. Just a minute. What he is doing is just opening the previous connection. So why he is doing that? Because here the sides will be opposite. So excitation will be at the high voltage side and shorting will be there at the low voltage side. Previously the excitation was there in the low voltage side. Okay, so therefore he is changing that. So he has opened that excitation. You just see he is opening the excitation terminals. He's not opening the shorting of two individual coils. He has changed the side. Now he will connect the excitation to the high voltage side. So this is how he is connecting to the high voltage side. Okay. And what he is doing now? Connecting 1 and 2. Can you tell me? He's connecting 1 and 2 by a wire. By this, what he is doing?
In series 1 and 2.
No, what he is doing now?
Short circuit. Yes, sir, short circuit.
It is short circuit because between 1 and 2 you have a coil. So if he connect 1 and 2 by a wire, that means he is directly short circuiting by that wire. That coil is getting short circuited. Not only that coil, another coil which is connected in parallel to that, that also will be short circuited. Because current will always try to follow the lowest impedance path, isn't it? So that means both the coils which are connected in parallel at the low voltage side will be short circuited by this process. Okay, so this is the short circuiting. So 1 and 2 are short circuited. So this only the change you have to do for the short circuit test. Meter you don't have to change because you have already changed the excitation side. Just a minute. I'll show you another video. So previously it was connected with the 125 volt pressure coil. Okay, but now it should be changed. Just a minute. Okay, so that means with the available range of pressure coil and current coil, okay, so you have to change the pressure coil terminal and current coil, sorry, rating of the pressure coil and current coil to measure the appropriate voltage. Now I will show this part of the video which will tell you how to calculate the, so I think it's not very clear, but here actually the depending on the pressure coil and current coil rating, you have different multiplying factor. Okay, so that you have to see carefully when you will go for the actual experiment, because when you are changing the current coil and pressure coil, then you have to note down the multiplying factor corresponding to that combination. Okay, because here we are varying this voltage as well as current, so we have to go for different current coil and pressure coil combination for different rating, different reading. Okay, but you have to carefully note down the multiplying factor for that particular combination of current coil and voltage coil rating. So that is given in this table, but this table is coming a little bit hazy. Okay. Let me see what else I have. Now I will show you that we have to change the voltmeter. The voltmeter which we have used for the open circuit test will not work for this, because that voltmeter had a minimum range of, I think, 150 volt or so, isn't it? Now the voltmeter which should be used for short circuit test should read very low voltage, because only 2 to 3% voltage will be dropped, as I told you, isn't it? So that means, you see, this is the new voltmeter. It's coming hazy, but I think it will be clear. Okay. So you see, this is 15. One range is 0 to 15, another is 0 to 30, another is 0 to 75. So 15, 30, 75. So this type of voltmeters are used for doing this short circuit test, because short circuit test, the voltage which will be developed will be very less. But as we have connected in the high voltage side, so little voltage you will get. If we connect in the low voltage side, we'll get the still low voltage, which will not be, we cannot measure that voltage with this type of voltmeter also. Okay, so that is the, and the current ammeter also we have to change here, because you see here the current which will flow in the rated condition will be quite high. For this particular transformer, it is 13.6 ampere rated current. So therefore, we have taken 10-20 ampere range of ammeter. Okay. Here the rated current will be very high, so we have to take higher range ammeter, unlike the open circuit test. So these two meters, voltmeter and ammeter, you have to change. Wattmeter, for wattmeter, we have to change the terminals only. You have to change the current coil and pressure coil only. Okay. Now I will go back to the circuit. So once we have all the instruments are connected, then we have to go for this run 2, that is the short circuit test. Connect the meters to high voltage side. and the low voltage side should be sorted as you have seen in the experimental setup. Vary the input voltage to the high voltage side starting from 0. Again, we are increasing the voltage starting from 0. So increase the applied voltage in steps so that the rated current is flowing in the high voltage side, not exceeded the rated voltage. Okay, so note the readings of V1, W, I in each step. So these are the 3 readings we require for doing this short circuit test. And here also we'll change the current from its 0 value to the rated current value. So that means here we will vary the variac only, but we'll keep watch to the ammeter. Though by varying the variac setting, the voltage changes, we'll keep watch to the ammeter reading. When the ammeter reading will reach the rated current value, then we'll stop varying the variac. Okay, so that you have to remember. Okay, so that is the rated condition at which you have to take all these readings. But you have to take all these readings for all the current values. But when you will go for this calculation, determination of equivalent circuit, then you have to take the voltmeter, ammeter, and wattmeter reading corresponding to the rated current only. The rated current can be calculated from the nameplate kVA rating and the voltage rating. Okay, so these are the post experimental calculations and report you have to make. But anyway, this time you are not, you will not have to submit this report. Anyway, so if you have any question on this experiment, you can ask. Anything?
No, sir.
Anybody? No, sir. So is it clear to you this type of experiment? The first time we are performing some experiment virtually.
Yes, sir.
Huh? So how you are feeling?
Sir, it was a very nice.
Doing the experiment virtually.
Thank you, sir. It was a very nice.
Better than practical one.
Sir, nostalgia feel.
Better than practical. Why? Why it is better than practical?
Sir, here we knew the theory from before, from machines 1. That is why it was very easy. But when we don't know the theory, then it will be difficult.
Okay.
Actually, sir, sometimes anyway, in practical, we are not explaining so well on the lab. So now you are explaining very well on virtual mode because we don't get access every time.
Okay, so lab এ যদি আমি থাকি তো আমি এটা এক্সপ্লেইন করি, মানে আমি সব সময় এই যে জিনিসটাকে এক্সপ্লেইন করা
আসলে সবসময় আপনাকে পাওয়া যায় না, এবারে আমরা সেরকম ভাবে পাই না, সেরকম মানে জিজ্ঞেস করি ল্যাবে, তো বলা হয় না আমাদের, তো আমাদের খারাপ লাগে, তো মানে ল্যাক অফ নলেজ থেকে যায়, ওর জন্য ওটা
ইটস ওকে। ঠিক আছে, তোমাদের আরেকটা এক্সপেরিমেন্ট আছে, ইউ হ্যাভ অ্যানাদার এক্সপেরিমেন্টস that also I have recorded some video and I will give to the concerned teacher who will be taking that experiment. Do you have the schedule?
Sir, টিচারদের I don't think এখনো আসে, জানি কে কোন টিচার কে নিচ্ছে, কোনটা নিচ্ছে।
ও তোমরা জানো না,
ডেটার নেম মেনশন করা আছে, কোন টিচার ফ্যাকাল্টি মেনশন করা আছে।
ও ডেটার নেম মেনশন করা আছে টিচারদের, আচ্ছা তোমরা জানো না তাহলে ঠিক আছে। ঠিক আছে, এই নিক, আমি তো ভিডিওটা শেয়ার করে দেবো। আর আই থিঙ্ক যেভাবে আমি করেছি এইটা তো ইউটিউবের লিংকে থেকে যাবে, আমি লিংকটা ওপেন রাখছি, কেউ যদি মানে ঠিকঠাক অ্যাটেন্ড করতে না পারো পরে এটা শুনে নিও। তো আমরা যেটা করব লাস্টে একটা ছোট্ট ইভ্যালুয়েশন টাইপের রাখবো, সেই জন্য তোমরা একটু এটা একটু ভালো করে দেখো কিভাবে কি করানো হলো। রিপোর্ট হয়তো তোমাদের লিখতে হবে না, কিন্তু some sort of evaluation will be there to give you some marks.
So is it like a viva?
So that we are no, that is not yet been decided. So that will be decided in some meeting. তাড়াতাড়ি একটা মিটিং হবে যাতে আমরা এটা ডিসকাস করব, মানে ডিসাইড করব যে কিভাবে ইভ্যালুয়েশনটা করা যেতে পারে। Some sort of evaluation will be there. So you should ready for that, not only for that. মানে একটা ইয়ার চলে যাচ্ছে সেখানে তোমরা একটাও ল্যাব করছো না, সেটাও তো খারাপ। সেই জন্য তোমাদের
অর্ধেক ল্যাব হয়েছিল, সব হয়নি।
হ্যাঁ, কিছু ল্যাব সেকেন্ড ইয়ারের আমি বলবো তোমাদের, আমাদের একটা মানে খুব আগে অনেকদিন আগে থেকেই আমাদের একটা ভার্চুয়াল ল্যাবরেটরির একটা পোর্টাল তৈরি ছিল। তো তাতে খুব ভালোভাবে এবং ইন্টারঅ্যাক্টিভ মোডেও এক্সপেরিমেন্ট করা যায়। তো সেটা আমি ভবিষ্যতে যদি তোমাদের পারি শেয়ার করব। এবারে সেকেন্ড ইয়ারে আমরা সেইভাবে এক্সপেরিমেন্ট করাচ্ছি ওই যে পোর্টালের থ্রু দিয়ে, কিন্তু থার্ড ইয়ার ফোর্থ ইয়ারের এক্সপেরিমেন্ট গুলো আমাদের ওই পোর্টালের থ্রু দিয়ে রেডি নেই, সেই জন্য আমাদের এইভাবে করতে হচ্ছে। কিছু না করাচ্ছে তো এটা ভালো, তাই না? Okay, so but anytime you can ask me question regarding this any laboratory in your third year. Anyway, so thank you very much for attending this session.
Thank you, sir.
So,
Thank you, sir.
I will expect this
Thank you,
type
sir.
of attendance in my theory class also.
স্যার একটা কথা ছিল
Today,
স্যার,
almost 90% attendance I got, but in theory class only 60%. Why so? I don't know. Anyway, বলো অমৃতা, কে বলছো?
স্যার হ্যাঁ স্যার আমি বলছিলাম যে আপনার ইলেকট্রনিক্স এর লাস্ট লেকচারের ওই রেকর্ডটা দেবেন স্যার।
আমি সব তো পাঠিয়ে দিচ্ছি ইলেকট্রনিক্স এর লেকচার, নাকি লাস্ট
লাস্টেরটা তো
লেকচারটা দেওয়া
পাঠিয়েছি
হয়নি
স্যার।
কি?
না স্যার ওইটা স্যার আমি আগের দিন করতে পারিনি, আমি লিখেছিলাম আপনাকে।
ও, লাস্ট লেকচারটা আপলোড করা হয়নি নাকি?
হ্যাঁ স্যার ওটা যদি দেন তো খুব
আচ্ছা ঠিক
বেটার
আছে,
হয়।
আমি করে দেবো।
আর এখানে একটা কোশ্চেন
আমাদের
ছিল স্যার,
কবে যেন শিডিউল ক্লাস থাকে?
স্যার মঙ্গলবার।
হ্যাঁ বলো।
স্যার এখানে যে
আচ্ছা,
কোশ্চেনটা
মানে
উঠলো
কালকে।
স্যার আপনি ওই
ঠিক আছে,
ওপেন
আজকে আমি
স্যার ওই ওপেন সার্কিট টেস্টে যখন আমরা হাই
বলো
ভোল্টেজ
শুন।
সাইডটা ওপেন সার্কিট
হ্যাঁ।
টেস্টে যখন হাই ভোল্টেজ সাইডটা আমরা ওপেন রাখছি, তখন স্যার ওই ওয়াট মিটার সংক্রান্ত যেটা একটা বললেন না, মানে ওখানে বললেন যে কেন রাখা হয়, ওখানে ওয়াট মিটার সংক্রান্ত একটা পয়েন্ট ছিল, ওইটা কি স্যার কি বললেন? এটা আমি ঠিক ক্লিয়ার করতে পারলাম না।
বুঝলাম না, আরেকবার বলো।
মানে স্যার
হাই ভোল্টেজে
হাই ভোল্টেজ সাইডটা আমরা ওপেন রাখছি, তো যদি না রাখি, মানে
হ্যাঁ।
যদি আমরা ওপেন না রাখি তাহলে একটা প্রেসার কয়েল সংক্রান্ত
হ্যাঁ।
একটা কিছু প্রবলেম ছিল, সেইটা আমি নোট করতে পারিনি স্যার।
ও আচ্ছা আচ্ছা, হ্যাঁ হ্যাঁ, সেটা হচ্ছে তোমার হাই ওয়াট মিটারটা তুমি যদি হাই ভোল্টেজ সাইডে রাখো, ইফ ইউ কিপ দ্য ওয়াট মিটার, ইফ ইউ কানেক্ট দ্য ওয়াট মিটার in the high voltage side, in that case the pressure coil rating you have to arrange in that high voltage rating. Suppose you have transformer of 11 kV, আমরা যে ট্রান্সফরমারটা করছি এটা তো খুবই একটা মানে ছোট ট্রান্সফরমার, মানে laboratory transformer. But if we go for actual transformer, that is 415 volt by 11 kV, is very normal transformer for distribution application. If we go for that, and if we connect the pressure coil or the watt meter, if we want to connect at the 11 kV side, then the pressure coil rating of that watt meter should have that range. So that means the 11 kV, 11,000 volts. Can you imagine? So you don't have any watt meter in that range, having the pressure coil in that range. So what you have to do then? You have to step down that voltage by using the PT, potential transformer.
PT potential transformer, ঠিক আছে স্যার। ওকে স্যার।
PT ইউজ করে সেটাকে কমিয়ে তারপর করতে হবে।
বড় মানে আমাদের ওই জেনারেটিং স্টেশনে বা ডিস্ট্রিবিউটিং স্টেশনে যে 50 কেভি বা ওরকম ধরনের যে ট্রান্সফরমার গুলো ইউজ হয়, ওখানেও কি এইভাবেই মেজার হয় ওপেন সার্কিট টেস্ট, শর্ট সার্কিট টেস্ট?
না, ওখানে তো টেস্ট কোথাও হয় না, টেস্ট তো হয় ল্যাবরেটরিতে।
ল্যাবরেটরি,
টেস্ট তো
আচ্ছা
হয়
আচ্ছা।
ল্যাবরেটরিতে, টেস্ট তো আর মানে সাইটে হয় না টেস্ট। টেস্ট হচ্ছে তোমার যে অ্যাক্রিডিটেড ল্যাবরেটরি হয় NABL বা এই ধরনের কিছু, আমাদের ল্যাবেও কিছু টেস্ট হয়, আমরা করি। তো এই ল্যাবরেটরি গুলোতে টেস্ট হয়, টেস্ট তো ওইখানে হয় না,
আচ্ছা আচ্ছা
সাইটে কখনো টেস্ট হয় না।
হ্যাঁ স্যার, ঠিক আছে স্যার, থ্যাংক ইউ স্যার।
এক্সামের ব্যাপারে
বলো।
কিছু জানেন স্যার?
আর
সেমিস্টার এক্সামের ব্যাপারে?
হ্যাঁ
স্যার সেমিস্টার এক্সামের ব্যাপারে কিছু জানেন? মানে কিরকম ভাবে হবে, মানে
সেমিস্টার?
ইয়েস স্যার।
সেটাও এখনো ডিসাইডেড না।
মানে স্যার যদি লাস্ট
বুঝেছো,
অপশনকে
সেটা
বলে
এখন
যে
ডিসাইডেড।
3 ঘন্টার এক্সাম হবে, মানে 100 নম্বরে, টাইম যদি না থাকে তার জন্য মানে আমাদের প্রিপারেশন করতে সমস্যা হবে না? ওই জন্য মানে যদি আগে জানা যায়।
স্যার পরীক্ষাটা কি ফুল সিলেবাসে হবে?
এইবারে মনে হচ্ছে না খুব একটা বেশি ফিজিক্যাল মোডে মানে হবে বলে আমার ব্যক্তিগত ধারণা, পার্সোনাল ভিউ। সেটা হচ্ছে এইবারে মনে হয় না যে তোমার ফিজিক্যাল মোডে পরীক্ষা নেওয়া যাবে বলে। ফলে যেটা হবে আইদার হতে পারে ইন অনলাইন মোড, ওকে, মানে অনলাইনে কোনো গুগল ফর্মে বা এই ধরনের কোনো একটা এতে প্ল্যাটফর্মে অনলাইন মোডে একটা সার্টেন টাইম দিয়ে কোয়েশ্চেন করে ইভ্যালুয়েশন করা যেতে পারে, 1 নম্বর। 2 নম্বর হচ্ছে জাস্ট মানে লাস্ট টাইম যেরকম করা হয়েছিল ওইটা একটা আরেকটা অ্যাপ্রোচ, অ্যাসাইনমেন্ট বেসড, যেটা অ্যাসাইনমেন্ট পাঠিয়ে দিয়ে তোমাদের স্ক্যান করে সাবমিট করতে হবে। এই ধরনের মোডগুলোই আহ, হতে পারে আর কি, আমার ব্যক্তিগত ধারণা। কেননা ফিজিক্যাল মোডে এই মুহূর্তে আমাদের যাওয়াটা কিন্তু সমস্যাজনক।
স্যার কিন্তু সব সাবজেক্টে কি ফুল সিলেবাস টেস্ট হবে? এটা কি কনফার্ম?
সেটা তো হওয়া উচিত, মানে সেটা
কিন্তু স্যার
তো
আমাদের পাওয়ারলেস
ইউনিভার্সিটি
সেকেন্ড পার্ট শুরুই হয়নি।
স্যার ডেটটা কি একাডেমিক
ইউনিভার্সিটি
ক্যালেন্ডারে যেটা দিয়েছে ওটাই?
একাডেমিক ক্যালেন্ডারটাও এখনো একটুখানি চেঞ্জ হতে পারে।
ওকে স্যার।
একাডেমিক ক্যালেন্ডারটাও হয়তো একটু চেঞ্জ হতে পারে, জানি না, সবই মানে শোনা কথা আর কি। কিন্তু ইউনিভার্সিটির এক্সাম কিন্তু মানে ফুল সিলেবাসই হয়, সিলেবাসটা কিন্তু চেঞ্জ হবে না। হয়তো যেহেতু আমাদের এটা একটা কি বলতে পারি, আমাদের নিজেদের আমরাই পড়াই, আমরাই কোশ্চেন করি, সুতরাং আমাদের অনেকটাই মানে এ রয়েছে, ফ্লেক্সিবিলিটি আছে। The question should be on the full syllabus. তো সেইটা ধরে তোমরা এগোতে পারো, কিন্তু মোড অফ ইভ্যালুয়েশন কি হবে দ্যাট ইজ নট ইয়েট বিন ডিসাইড। তবে আমার পার্সোনাল ভিউ যেটা বললাম তোমাদের, যে এবারে কিন্তু ফিজিক্যাল মোডে 3 ঘন্টা যেভাবে তোমরা সেমিস্টার পরীক্ষা দিয়ে এসছো সেইভাবে নেওয়াটা একটু ডিফিকাল্ট।
হ্যাঁ স্যার, মানে
এখনো
বাড়িতেও যদি
কিন্তু
3
সেই
ঘন্টা বলে স্যার, 3 ঘন্টার মধ্যে লিখে মানে জমা দিতে হবে, মানে সেটা তো সমস্যা হয়ে যাবে। মানে ওই জায়গাগুলো একটুখানি আগে জানতে পারলে আমাদের।
আচ্ছা 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 আচ্ছা, না সে নিশ্চয়ই বলে দেবে, ইউনিভার্সিটি থেকে নিশ্চয়ই বলবে, তোমাদের জানাবে, ডিপার্টমেন্ট থেকে জানাবে, কিন্তু সেটা এখনো হয়নি। সেটা নিয়ে আমাদের শীঘ্রই একটা মিটিং হবে, সেখানে যা ডিসিশন হবে সেগুলো তোমাদের কমিউনিকেট করা হবে। ওকে, সেটা এই মুহূর্তে এখনো মানে ডিসাইডেড হয়নি। আর ইউনিভার্সিটির তো একটুখানি আনরেস্ট হয়েছিল, তো সেটা নিয়ে এখনো সবকিছুই একটুখানি মানে স্টেটে আছে আর কি, ভোলাটাইল স্টেটে আছে সবকিছু, কোনো কিছু এখনো সেই ফিক্সড হয়নি আর কি। ওকে, এনিওয়ে, তো